Hi, I'm Vera Kempe from Abertay University, and I'd like to thank the Summer School of Linguistics for inviting me to give this presentation, in which I'd like to talk about our recent work on using artificial language learning to study whether being exposed to dialect may or may not affect literacy learning. I also want to acknowledge my colleagues, Glenn Williams and Nick Panayotov, and also our funder, the Levenik Trust, without whom this project would not have been possible. So our interest in this topic was piqued by headlines that appeared in the press back in 2013, reporting on some head teachers who were banning dialect use in their schools out of fear that it might impair their students' learning progress. So this particular head teacher describes the problem as follows. If children are using certain phrases, that can be confusing for them, because when they come to spell the word, they're not saying it in standard English, and that can hold them back. It is indeed the case that English spelling follows a standard. And this standard is based on a specific high prestige dialect of English that was codified between the 14th and 17th century. In fact, English spelling, as we know, has not changed much since 1650, while the way the language is spoken has changed quite a bit since then. And as a result, English, as we know, is not really phonemic in the sense that specific graphemes can be pronounced differently or not at all, as in the example of me, in different surrounding contexts. However, in exchange for the inconsistency, it has to be acknowledged, in the inconsistency in the relationship between spelling and sound, English gets a considerable degree of morphemic consistency. So some parts of words are spelled the same way, even if they are pronounced differently, like the S in cats, dogs, and horses, because they express a specific grammatical function, plural in this case. A much more complex question is whether there is a spoken standard of English. What such a standard should be is actually not easy to define. Some define it by exclusion as absence of regional or vernacular features, and others associated with the social characteristics of its speakers. But I would like to point out that if we take, for example, received pronunciation as the spoken standard of British English, that does not necessarily by itself give great advantages for spelling, as the received pronunciation has considerable inconsistencies as well. For example, to do with the silent R that can create many similar sounding words like caught and court. My American pronunciation is not really good to illustrate that, but you get the idea. These words are spelled differently, but in RP are pronounced the same, yet mean different things. It's important to note that varieties of British English vary on several dimensions and differ in how explicitly they are codified. For example, received pronunciation is considered to be overtly codified and the prescribed standard. But there are other standards, like standard Scottish English, which are not always used in a prescriptive manner, but are considered standard and higher prestige varieties nonetheless. So these differences in social prestige and the associated differences in learning contexts is what makes disentangling how cognitive and social factors may affect learning in situations of exposure to different varieties really challenging. And there may be a number of problems associated with not using what is perceived as the standard variety. So first, there may be effects of different social attitudes towards speakers of non-standard dialects. But this is not the focus of our research here. We're also not interested so much in the problem of whether children will produce many non-standard grammatical constructions in their writing. So write phrases like me and me mate was walking home. Whatever little research there is on this topic suggests that they don't very much, and it actually doesn't seem to be a big problem. What we were interested in is to find out whether that head teacher may have had a point if non-standard use affects the very early stages of literacy learning to read and to spell. And if that was the case, that would indeed be a problem. So to give an example from one variety of British English, from Scots, whether when children learn to read words like house and mouse, confusion may arise because they don't know whether to read it as house or hoose, or mouse or moose. Now, I'd like to point out that although I've been speaking about British English as an example so far, the problem is potentially not unique to Britain or even to the Anglosphere. So here are some examples of other languages and regions that also have considerable dialect variability. So I'm showing you here on the left dialects of German, then in the middle Italian, on the top right Arabic, and indeed on the bottom right regional varieties of American English. So why should we assume that knowing dialect variants, being exposed to them before literacy learning commences, may make learning to read more difficult? We know from psycholinguistic experiments looking at reading speed that it takes readers slightly longer to read words that have two different pronunciation variants, such as wind versus wind or lead versus led. And reading such words takes slightly longer than words like spring that have two different meanings, but only one way to pronounce them. So these words on the left, words like wind and lead, lead, are called heterophonic homographs. And they are more difficult to read because the spelling activates two competing forms in the reader's mind. And it takes the brain about 50 milliseconds or so to resolve that conflict. True, this cost in speed is minute, but it's measurable and it's statistically significant. And if even adult experienced readers show these slight delays, then it's possible that children who are just learning to read may have even greater difficulties. So by analogy then, we can speculate that words for which the dialect variants are slightly different, so house, whose, we call them contrastive words, may create similar competition in the mind that needs to be resolved. And this may present a problem in early literacy acquisition. If such a competition occurs frequently, then one would predict that children exposed to dialect should have some difficulties with literacy acquisition. Is there any evidence for this? It turns out that there is surprisingly little relevant research, and whatever research has been conducted mainly in the context of non-standard, non-mainstream varieties of American English. A meta-analysis, a statistical technique that pools the data from several studies, looked at all studies that had compared literacy learning outcomes between children using mainstream and non-mainstream American English. And this meta-analysis showed a small to medium-sized effect of exposure to non-mainstream English in such a way that children exposed to non-mainstream varieties scored slightly lower on a whole range of literacy outcome measures. But of course, it's impossible to say from these data whether the effect was due to the competition between variants that I just described and the resulting cost that comes from that competition, or whether it's due to a host of other environmental factors that may affect learning. It should be said that this study tried to control statistically for socioeconomic status, but the measures for socioeconomic status that were implemented are fairly crude measures and do not capture many of the environmental factors that may play a role in literacy learning. And there can indeed be a whole range of such factors. especially if one takes into account that many non-mainstream varieties are also socially stigmatized, which may result in different quantities of language input, different educational opportunities. The teaching methods may be different and may play a role. So, for example, is phonics used or not? Different social attitudes towards the dialect, and so on and so forth. So, our goal was to disentangle these environmental factors from linguistic factors to see whether dialect per se may play a role in literacy learning. And one way to do this is to use miniature artificial language learning, which is a widely used methodology, and combine it with an artificial invented script. Now, experimental psychologists are, of course, not the first ones who invented artificial scripts. There are well-known precedents, for example, in sci-fi and fantasy movies. So if there are any Trekkies amongst you, you will probably have recognized Klingon on the left. And probably most everybody knows about the Elvish languages from The Lord of the Rings. And also the alien language in the movie Arrival is another interesting example of what you would call an invented script, although I'm not entirely sure whether it's a writing system or just a visual language. In any case, these are well-known and sophisticated constructed languages. The ones we're using in the lab are much more modest, of course. But the basic idea behind the use of artificial languages and artificial scripts is that we can create mini languages with dialect versions, and we can teach some participants words in just one variety, and then use the same words when teaching them to read and to spell using the invented script. And we can use another group and teach them words in another variety, but then use the same variety as the first group when learning to read and to spell, as illustrated here in this graph. And at the end, we can compare whether learning outcomes for reading and spelling between these two groups differ. We can compare this not just for the words that participants will have learned, but also for novel, for untrained words. And this would be important because in real life, reading novel words is the main source of vocabulary growth. And also having children read unfamiliar words, sometimes non-words, is the best way to test, to see whether they have grasped the links between spelling and sound in their language. So before I continue and tell you about the results of the study, I need to clarify why I'm switching between the words dialect and variety. So I'm just trying to preempt one question that usually comes up when I talk to people about this research, namely, can we define what the difference is between a dialect and a language? And the short answer is we can't. Mutual intelligibility is not a good criterion, and people's perception of what's a dialect can differ widely. So, for example, Norwegian and Swedish are mutually quite intelligible, yet they are considered different languages, while Cantonese and Mandarin are considered different dialects of Chinese, but they're not mutually intelligible. So if you're interested further in this aspect, the QR code on the top right of this slide links you to a very nice article by the American linguist John McWhorter, which is written for a general audience, who gives a very clear account for why we shouldn't even try to make that distinction. So a better way of looking at this is consider all of this, registers, accents, dialects, languages, as different varieties that differ on a continuum of similarity and mutual intelligibility, as I tried to illustrate here. Still, I'm using the term dialect simply for ease of reference because in the context, especially of, for example, British English, most people have a good notion of what we mean by this. So we mean varieties like Cockney, like Doric, like Dundonian, Geordie, Scouse, etc., etc. Okay, so back to the project. So when constructing our mini language, we needed to determine in what ways the two varieties should vary and how many words in our mini language should have dialect variants. Now, normally one can glean such information from what's called parallel corpora. So the same piece of content rendered in different languages or different varieties. For example, linguists who want to study how different languages express the same content have used the parallel Bible corpus, which exists in about 100 languages. But to our knowledge, no such parallel corpora exist for dialects. So we decided to construct our own, and we took advantage of the fact that Julia Donaldson's wildly successful children's books, The Gruffalo and The Gruffalo's Child, had been translated into all these different varieties of Scots. And we took these different translations and we simply tallied up how many words differed between the English Gruffalos and the Scots Gruffalos, and in what ways did they differ. And what we found is that while roughly half of the words are the same in all varieties of English and Scots, about 20% differ considerably in that they are actually different lexemes, like child in English is bairn in Scots, or slippers in English is baffies in Scots. But the majority of variants are characterized by sound substitutions. So variants like house and hoose and mouse and moose. And for this project, we decided to focus on these, on the phonological changes. And we created a version of our mini language where half of the words differ in one or two sounds. So this is what we decided to implement for this artificial language study. Only the variants that have phonological changes, not the child bairn variants. So here's our mini language. We called the language Levenik, which is an acronym combining our first names, Glenn, Vera, and Nick. But crucially, in the dialect version, 15 out of 30 training words have a dialect variant, which is shown here in the middle. The table in the middle shows the 15 words that have a dialect variant, right? So one group received all the words that are sort of marked in this kind of orangey brown color. And the other group received the 15 words on the left, and then the 15 words that are in the column called dialect variants. And on the right, I'm showing you the untrained words that we used for testing at the end. And this is the artificial script we created to go with the language. The script was carefully constructed so that the signs would not resemble any known letters anywhere, to the best of our ability, but also would not be too visually complex. And I should note that to control for accidental resemblances that each participant or that people may perceive in these artificial letters, each participant got a different assignment of letters to sounds. So assignment of letters to sounds was randomized across participants. Now, I'll give you a few seconds now to memorize these letters, and then you'll get a chance to test yourself in reading the script to get a flavor for the difficulty of the task. So take a few seconds. And in the next slide, I'll show you a word in Levenik, and you'll have to try and read it. So here we go. What is the correct reading of this word? And if you picked C, you were right. So I'll give you a chance to verify this. Now, we programmed the learning experiment to be administered online, and we recruited participants through crowdsourcing platforms like Mechanical Turk and prolific academic. And that gave us the opportunity to test many more participants than what we would have been able to test in the lab normally. So we had 80 participants per condition, and this is the experimental procedure. So participants first were exposed to all of the 30 words. Then they were exposed to the letters. They learned the alphabet, as it were. Then they were exposed to the words again. Then they learned to read one block of 10 words. They learned to spell it. And they went through this 3 times, interleaving exposure to the words with reading and spelling training of the other 2 blocks. And then finally, so they went through this 3 times. And then finally, they were tested in reading the trained and untrained words and spelling of trained and untrained words. And reading and spelling order was counterbalanced across participants. So crucially, reading and spelling training was interleaved with more learning of words. What we aimed to emulate here was a situation where a child hears one variety during the day at school and another variety when they come home to their family. And at the end, as I just said, they were tested for reading and spelling in all the words that they had learned and a set of new words that they'd never seen before. And this is similar to when primary school children are tested with reading of non-words to see how well they have learned to assemble the sounds of words from the letters, as is taught, for example, through the phonics approach. So let me just briefly describe to you our learning outcome measure. When participants read a word, we recorded that. And when they typed a word in the spelling test, we logged that too. And then from this output, we computed what is called the edit distance. And that's a measure of how much a produced word, the reading or the spelling, deviates from the target word. And that's done by counting up the number of insertions, deletions, and substitutions of letters or sound one needs to get from one word to the other. So imagine the target word is sitting and the participant produces something like kitten. Then we arrive at an edit distance of 3 because it involves 2 substitutions and 1 insertion, right? So substitution of S for K, substitution of I for E, and the insertion of G at the end. And that is then normalized by dividing the length of, it by the length of the longer of the 2 words. So we can compare this measure across Levenik words of different length. So here are the results. Let me walk you through this graph. This is a rain cloud plot which shows for each condition the average edit distance for each individual participant, and on the right, the density plot showing how these data are distributed. So the graph plots edit distances. So the lower the points, the better the performance. And the first thing to note is that there is enormous variability. Some people are really good at this and others aren't, or maybe they were just not paying as much attention as they should have. But despite this variability, we still get statistically significant results. So we see that in the dialect group, performance was worse when reading the contrastive words compared to the non-contrastive words. So words that have a dialect variant, we get higher edit distances, worse performance compared to words that didn't have a dialect variant. So this hypothesis that having 2 variants for one word may come at a cost, albeit a very small one, seems to be supported by these data. Now, the other finding to note is what is happening with reading of the new words. Participants in the dialect condition actually performed better. So in order to explain why this might be the case, why they may have performed better reading untrained words, We need to briefly consider models that can help us to understand what processes are engaged when reading and spelling. So if we take the model proposed by Harm and Seidenberg, each word comes in three incarnations, as it were. We have the meaning, the semantic representation, we have the word sound, and we have its spelling or its orthographic form. So how do we get from one to the other? When we read, we need to get from the spelling to the sound. And one way of doing it, of course, is to decode each letter and assemble the sound. And this is what phonics education actually teaches. And it is the main route to decoding words we do not know. But as readers or learners get more experienced with reading, they may be able to link the overall shape of a word's spelling directly with its meaning, and then retrieve the sound from there, just as one would in word production. So the interference that arises between the two variants is only an issue if readers try to retrieve the sound from the meaning directly, as they have gained more experience with recognizing the spellings of words. If they were to decode a word from scratch, letter by letter, then having a dialect variant or not should not matter. At the same time, when we get a new word for which we have no meaning to access in our internal representations, then we need to decode the orthographic form. And what our data show is that in the dialect condition, participants were somewhat better at doing this decoding of novel words. And it may be that because there was more variability in the input that they encountered overall, they were more likely to practice decoding to avoid trying to decide between the two variants. And that may have made them perform better with the new words. So here are the data for spelling. And we see absolutely no differences between the groups and between the different words. And what this means is that when having to assemble the spelling from sound, learners, of course, do this through a decoding or a conversion process, because accessing the spelling from meaning directly is very difficult in alphabetic scripts. In fact, alphabetic scripts are designed to actually circumvent this option. Okay, so we see a slight cost of learning to read words that have a dialect variant, but we don't see any cost in reading novel words. In fact, we see a slight benefit. So far, I've been talking about this research in terms of trying to find out how the processing system would deal with the greater variability that comes from being exposed to different variants associated with dialects, and whether this may create problems with literacy learning. And from these data, two interesting questions arise. First of all, what if we make learners directly aware of the fact that words belong to different varieties, which are being used in different contexts? And I'm illustrating contexts here schematically by different regions in these two pictures. So associating specific variants with different contexts may make it easier to process the different variants, because the learner now knows that in any given situation, only one variant is relevant. And there's actually some evidence from educational research in the US that this could be helpful. So could associating variants with different contexts, for example, regional contexts, eliminate the small cost of having two variants represented in memory that we saw in the study that I've described so far? And the other question is, what would happen if we were to teach learners directly to read and to spell in the dialect, as is done in some educational authorities? For example, here in Scotland, there have been attempts to teach children dialect reading and dialect spelling, and there have also been attempts in some Scandinavian countries and in the US, but there is very little empirical evidence as to what the effects of such policies would be. So in our second study, we built such interventions into our artificial language methodology. The first two groups in that second study were similar to the previous study, but in the third group, the dialect plus social group, we gave participants a cue as to where each variety was spoken. And we did this by associating it with these different pictures of the coast versus inland that I showed you earlier. And we also linked that to different voices. And in the fourth group, the dialect literacy group, we taught them reading and spelling in both varieties. And again, as in the previous study, we had 80 participants in each group, making for a total of 320 participants. So just to geek out a little bit on the experimental methodology, we had one more modification. Instead of interleaving dialect word learning and literacy training, we pre-trained all the words in an attempt to more realistically simulate the kind of word knowledge children acquire before they start school. So in fact, our previous experiment was more like a situation where word learning co-occurs with literacy learning. But in fact, children tend to know already the words they're taught to read and spell, at least in the early stages. And we also checked how well participants had learned the artificial words before they started literacy training. So participants were exposed to the words. They cycled 3 times through the entire set of 30 words. Then they received the vocabulary test. Then they were taught the alphabet. Then they learned to read and spell all 30 words, and they cycled through this 2 times, followed then by the reading and spelling test for the trained words and the untrained words. So I'm presenting the results here slightly differently, namely as the difference in edit distances between the contrastive and non-contrastive words. So the important thing to look for is whether these little density distributions straddle the line of 0. If they do, if their mean is close to 0, then that means there is no difference between edit distances for contrastive and non-contrastive words. But if they are removed from the line of 0, then there is an effect. So if they're shifted to the right of 0, that means there is a cost for producing contrastive words. And what we see indeed is that the contrastive words were appreciably more difficult to read and to spell when literacy training happened in both varieties. So we saw this contrastive deficit only in the condition where participants were taught to read and to spell in both varieties. However, if we then break down the contrastive deficit by how well people actually had learned the words, because we had a vocabulary test after our vocabulary training phase, we find that those participants who had managed to learn the words well actually showed a greater cost for processing contrastive words, pretty much in all conditions, in all dialect conditions, I should say, than those participants who did not learn the words very well. While the good learners performed better overall, the relative difference between contrastive and non-contrastive words was larger for these learners. Now that seems counterintuitive, but it makes sense. The better a learner has learned the dialect variant early on, the more it can interfere with access to the standard variant during reading. And this confirms that as words become more entrenched, readers will try to bypass decoding, phoneme-grapheme conversion, and will try to access the meaning directly, perhaps from the first 1 or 2 letters, and then try to retrieve the whole sound of the words just from there. And that then leads to the conflict as to which of the variants to retrieve. Now, you may have noticed that there was also a contrastive effect in spelling, as I pointed out in the dialect literacy condition. And this is probably due to the fact that when the learner goes through the spelling process and has to click the buttons for the individual Levenik letters on our virtual keyboard, during that time, they need to keep the word in mind because this spelling process takes time. And so this process of keeping the variant to spell in mind, in short-term memory, is also prone to interference from the alternative variant for those participants who were consistently exposed to the dialect in reading and spelling training. So this is the last figure, I promise. And this figure just compares how participants performed with the novel, the untrained words in all 4 conditions, and reading on top and in spelling in the bottom row. And if you look at just the grayish distributions on the right across all conditions, you can see that there was absolutely no difference between conditions. Why is that? Again, as I said previously, because the only way you can read or spell a novel word is by systematically decoding and converting each letter into a sound and each sound into a letter. And this does not seem to depend on whether the words you know have different variants or not. So there is no detriment for reading novel words. Now, the question is, why was there no benefit like in the previous experiment? And we think presumably it's because overall participants in the dialect conditions had the vocabulary practice with the dialect variants early on, so they encountered somewhat less variability. Now, to sum this up, what these experiments have shown is that dialect exposure can lead to a small cost when reading contrastive words, words that have a different variant. If the sound of a word is retrieved as a whole via its meaning, then competition between the 2 variants can arise. And it arises paradoxically more so in those people who learn the words better. Now, effect of dialect literacy, teaching learners both varieties in the early stages of literacy learning, could actually exacerbate this effect. And so this is an intervention that should be tested further. But what we also found is that dialect exposure does not impair reading and spelling of novel words. And I think this is very good news. So while, of course, artificial language learning allows us this tight control over environmental factors to see how the cognitive system deals with this challenge, there are, of course, caveats associated with the size of the language. So what we present participants are very small toy languages, and we do not know how this scales up to languages that are at least 3 orders of magnitude larger in terms of vocabulary size. Also, we tested adults to provide proof of concept. And we tested adults mainly because this task turned out to be very difficult for children, but also because children who actually undergo real literacy training probably should not expend much time and energy to learn some made-up language with no practical utility. So we were mindful that exposing children to our artificial language learning when they're actually engaged in real literacy acquisition may distract from this task. But what that means is that we do not know whether this main finding that reading novel words is not affected by dialect exposure extends to children who have yet to discover the alphabetic principle. So adapting our methodology so that it is usable by children is a challenge that we currently trying to address in my lab. And let me finish by showing you some of the references that describe the empirical findings that I talked about here, and by asking you to reach out to me by email or on Twitter for any questions and comments. And thank you very much for sitting through this.